This video is about how to properly light an LED. First of all, what is an LED? An LED is a two-terminal device that emits light. It is actually a diode. A diode is a device that only passes electricity in one direction. More specifically, current goes only one direction in a diode. An LED is a diode, and it needs to be hooked up a certain way in order for it to light. If you hook it up backwards, it won't light. So, also, you need to make sure that for an LED that you don't allow too much current to go through it, otherwise you'll burn it out. So I have a couple of examples here of LED circuits. This is a breadboard with what's known as a current limiting resistor. So you need to have a current limiting resistor in there to keep from burning the LED out. Here's what can happen if you do not use a current limiting resistor. This is a 9-volt battery right here. And I'm just going to take a perfectly good LED right here. And I'm going to show that it's a good LED. Let's go ahead and plug it into this circuit right here. Now, this is a good LED, perfectly good LED. All right. So let's go ahead and put this one back in. So I'm going to try to connect this. And by the way, the LED has a positive side and a negative side, which goes back to the current only going in one direction. So the positive side, also called the anode, is the long lead, typically the long lead on the LED. The short lead is going to be the negative side. So on a battery, the positive side, a 9-volt battery, positive side is the small side, negative side is the big side. But what you don't want to do is connect an LED directly to a battery, because too much current will go through it and it'll burn it out. So if I did that, okay, it just flashed. Boom, just like really quickly just flashed. And now that LED is no longer any good. So I'm going to go ahead and hook this up back in the circuit here. And we're going to see that it doesn't work anymore. Okay. Let's go ahead and put our other LED back in there. Okay, so we just burned this LED out by hooking it directly to a battery. So you don't want to just connect it directly to a power source, you'll burn it out. So that's why you need what is known as a current limiting resistor. Why do you know what type of resistor to use? Well, it's really easy. A typical LED has what's known as a voltage drop across it. And that voltage drop for most general LEDs, typical, is going to be somewhere between 2 to 2.5 volts. It really depends on the color. For most red and green LEDs, it's going to be around 2 volts. So you have 2 volts across this LED, 2 volts. All right, so you have 9 volts here, and you have this is your LED. So you have your current limiting resistor here. You have the LED drops 2 volts. Since all these voltages have to add up to the total, that's the way circuits work, that means that you only have 7 volts across this resistor. Now, the current of the LED is one of the factors you're going to need to use here. Now, you don't need to go through all these calculations to light LED, because once you know the resistor value that I'm going to give you, you can light an LED. But I'm going through this for people who want to know how to actually do this, how to actually calculate the resistor value. So most LEDs have a maximum, general purpose LEDs have a maximum current of around 20 milliamps, which is 21 thousandths of an amp. Current is measured in amps. So most LEDs is maximum of 20 milliamps. But to get a nice brightness out of it without burning it out, you'll want to go somewhere between 10 to 15 milliamps, which is 0.01 to 0.015 amps. Milliamp again is a thousandth of an amp. All right, so in order to find that resistor value, you're going to use this simple thing called Ohm's law. This is the Ohm's law triangle. To find the resistor value for the Ohm's law triangle, you'll cover up the R. What you're left with is V divided by I. So you have your voltage across that resistor of 7 volts. So R equals 7 volts divided by I, the current. We know our current is supposed to be somewhere between 10 and 15 milliamps. Let's go ahead and use 15 milliamps, which is 0.015. Okay, so if we go ahead and we calculate the 7 volts divided by the 0.015, it gives us 466 ohms. A very common resistor value is 470 ohms. Okay, so we want to be somewhere between 10 and 15 milliamps. If we did 7 volts divided by 0.01, which is 10 milliamps, that's going to give us 700 ohms. So we want a resistor value of somewhere between 466 and 700 ohms. So for this example, I'm just going to use 680 ohm resistor because it's handy. And we're going to have, if we do that, use the 680 ohm resistor. If we use that 680 ohm resistor, we're going to have just over 10 milliamps. So this is 680 ohms. We'll have approximately 10 milliamps, just a little bit more than 10 milliamps. I'm coming up with 10.3 milliamps. That's what this is. This is a 680 ohm resistor, and we have an LED that is working and has its current limited by this resistor. So let's go ahead and measure the voltages here. Now this is actually another example here. This is a 680 ohm resistor in series with an LED to the LED. So that works great with that resistor in series with it. And it'll basically run forever, just until that battery runs down. And there's an easy way to calculate it, but this battery will last about 8 or 10 hours like that with this LED. Okay. So let's do the measurements here. And I have what is known as a current meter, better known as an ammeter. And this ammeter will tell us how much current is flowing through the LED circuit. I've actually already got it hooked up. So yeah, we'll go ahead and turn the light on. Okay, we calculated just over 10 milliamps, and we've got 10.55 milliamps flowing through the circuit. Great, it's good. And we have here a voltmeter. Oh, there we go. All right, so the voltage across the LED is 1.9 volts. Okay, so that's about what we expect. And the rest of the voltage are going to be across this resistor. We have a 9 volt supply here, so it's going to be, it's probably going to be 7, a little over 7 volts, 7.08 volts. So that's what we would expect there. So that's how you light an LED. You limit the current going through it, and you have to hook it up a certain way. If you hook it up backwards, the LED is not going to work because it's a diode, and it has to, current can only flow one direction through an LED. And that's how you properly light an LED.
I hope you found this video interesting and informative. If you did, please like this video and subscribe to this channel. For more detailed information on this project, as well as recommended breadboarding equipment, best practices, and safety tips, please go to breadboardcircuits.com. Thank you.